All right, so for this, we're supposed to be solving for x. And if you notice, we have x here as a part of the coefficient of log 2. And then you're seeing x here as a part of the exponent power. All right, so we don't want to have the two things, right? I think we can either get both of them to be in a power form, or we could get all of them to be in coefficient, meaning it's either I'm going to work with x's like there, or I'm going to try to work with it here, but we're not going to work with the two different things, all right? So basically then, one of the log rules would suggest that if we have this, I'm just saying to you, if you have, say, the log of, say, 2 raised to the third, this is the same thing, right, as knowing that the exponent becomes a coefficient. So it's going to be the same thing as having 3 coming as a coefficient, and then you have the log 2. So this is something that you have to recall, that idea, right? So in recalling that idea, we are seeing where we could rewrite this right now. We could do that. Also, I can manipulate the 8 to look like a 2 as well. So remember, 8 is actually seen as 2 to the thirds. So if you really think about this, basically, if you see 8 to the x, basically you have 2 to the third with x outside. And based on the laws of indices, this is the same thing as 2 raised to the 3x. So you could see I can rewrite my 8 to the x as 2 to the 3x. So, for example, in solving this, there are many ways to solve a problem. I'm just saying we can rewrite. So we could have 3x. Then we have log of 2 plus. Now I'm just going to just rewrite this before I do anything. So this can be written as 2 raised to the 3x. And this is equal to 2. So now I have used exponents, which is what we call the laws of indices, to represent 8 to the x as 8 to the 3x. And then that would have produced this. Now what we want to do now is to employ this one now, where the power of the log becomes a coefficient. For example, so I'm rewriting again, 3x log 2 plus 3x again log 2, and that is equal to 2. Take a look at that. So we have 3x log 2 plus 3x again log 2. Yep. So we're seeing that a number of times right there. But this, if you really look at it, you would see that, oh, you're actually seeing that 3x log 2 times. So we can do something with that if we want, right? We can do something with that if we want, because that is actually 6x log 2. Yes, 3x log 2 plus 3x log 2. Think about it. 3x log 2 plus 3x log 2. So that's like having 6x log 2 equal 2. Because 3x becomes 6x. Plus, we're adding them. So I'm just saying, you understand? Or you could have looked at it as 2 times 3x log 2, and then that 2 would have affected the 3 and turned it into 6 anyway. So it's the same idea, all right? So right there, we're seeing where we turn this into this. And remember, you're solving for x. It's x you're solving for. So technically, the math is actually done because based on your transposition, you can leave the x there because I'm only having an x here. So then if I divide both sides by 6 log 2, look at this. 6 log 2. Then x will be on that side, and this is going to equal to 2 divided by 6 log of 2. And it's done. Right there. Right there. And if you want to break it down some more, you could say 2 into itself 1, 2 into this 6, 3, and you are left with 1 over 3 log of 2. And definitely, this could go on your calculator, and you get an answer for that. The thing